Okay, so I'm going to have a go at question 2 in the exam. So what's it say? Translate the following C function sum squares into equivalent assembly. The use of registers must satisfy the ARM calling convention. You should write square as a separate function and call it within sum squares, same as the original C code does. Okay, so we've got this function here square, this function here sum squares. We have to work out how to translate this code into assembly. So first thing I'm going to do is make sure I've opened the correct folder. So I go to VS Codium, open folder. I'm going to navigate to where I've put the files. Where did I put it? I put it in test, and then here we go. So here's the zip file that I've already decrypted and decompressed. And navigate to the question 2 folder and open that. Okay, so now I've got all these files here to play with. What's its first question say to do? So we got in sumsquares.s, that's where we're going to write the equivalent assembly for this function. So if I open, let's see what we've got here. So main.s just calls sum squares. And if we want, we can modify the input argument. Again, because it must satisfy the ARM calling convention, the input to the sum squares function lives in R0, and the output of it must also go in R0. And then we've got the sum squares file. Here's the code that we've got to write. So we've got to write a function that performs this operation. So we'll first write the function square. So it takes one input, which should be in R0, and it will return the square of that number, also in R0, satisfying the ARM calling convention. So that one's pretty easy to do, because we can just multiply R0 by R0, and then immediately return. So we're done. That's the squaring function. Now we're going to write the sum squares function. Okay, so what does this function do? So it takes as input in R0 the value of n. So I might write that down. Input R0 equals n. And the output is going to be the sum of the squares. All right. So we might use, let's say, R1 to record the total so far. So we'll set up R1 to be 0. So that'll be my total. And I might use R2 for this counting variable I. So mov into R2, that also starts at 0. That'll be my counter I. And then what do? We have some sort of loop here. While I is less than n, do some stuff. Okay, so I'll set up my for loop. So sum squares loop. First thing I do when I enter the for loop is I check if the condition holds. So I have to check if while I is less than n, run the code. So I guess the termination condition when I equals n, this code is going to stop executing. So I'll compare I to n. So compare. Now there's a little problem here. R0 contains n, but when I call the square function, it's going to screw up my value of R. So what I might do first off is copy R0 into R3, and that'll make my life easier. So move into R3, R0. So we use that to record the termination condition n. If you have to use more registers, R4 through R11, that's fine. But you just got to remember, you should push and pop them to the stack, because to not do so would violate the ARM calling convention. Okay, so what am I going to do? I'm going to compare I to n, so I'll compare R2 to R3. And when they're equal, that's going to be my termination condition to tell me to stop. So BQ, I don't know, sum squares loop exit, and we'll worry about what that is in a moment. So if the loop's not finished, what should I do? I should square I and then add that to the total. So I is stored in R2. So I guess I will mov R2 into R0. And then I will square it. So I'll call it the squaring function. And then I will add that to the total. So the result of the squaring function will be in R0. Add it to my total in R1. So add R1, R0. So that's all the for loop. And then what we have to do at the end of the for loop is run the increment condition, which is add 1 to I. So I is stored in R2. So add R2, 1. And then run the loop again. B sum squares loop. Okay? And then when the loop exits, sum squares loop exit, what should I do? I need to return the total. So I need to copy the total, which is in R1, into R0. And then BXLR. There we go. So I might test this function by running it with n equals 5. And what's the answer I should expect? It looks like this will compute the sum of the squares from 1 to 4. So 1 squared plus 2 squared plus 3 squared plus 4 squared, which is what? 1 plus 4 plus 9 plus 16, which is 30, I think. So let's run that and see what we get. So I'll go to my main code. I'll put a 5 in R0 just for the sake of testing it. I'll open the debugger. I don't have my dev board plugged in, so I'll pick build and debug emulator. And we'll run the code and we'll see what happens. There's my debugger. Give it a moment. There we go, got my debugger working. So we'll keep an eye on the registers and we'll watch what happens as the code executes. So we set up R0 to be 5. We jump to the sum_squares function. Okay, set up the total to be 0, set up I to be 0, and then we move n into R3. So this is telling me where I should stop counting up to. So I check if I should terminate yet. I check if I, which is in R2, is equal to n, which is in R3, and it's not, so we don't jump there. I then move R2, which is I, into R0. So I can get ready to square the number. So the first thing we'll do is going to square 0. So the BL function will square 0, and obviously 0 squared is 0. I add 0 to R1, 0 plus 0 is 0. I add 1 to my counting variable, I, in R2, and then we run it again. So, am I done? No, so I don't branch. I set up 1, and then I square it. 1 squared is 1. I add that, I add 1 to my counter, try again. Am I done? No. Move 2, 2 squared should be 4, so we'll keep an eye here. R0 was 2 before, and now it's 4, so that looks like my squared function is working correctly. Add that, so we add that to the total, so the total is now 1 squared plus 2 squared, which is 5. Run it again, and so now we should get plus 3 squared, so plus 9, and then 9 plus 5 is 14. There we go. And then one more loop. Are we done? No. So then we square 4. 4 squared 16. 16 plus 14 is 30. So then I should stop at this point. I then check R2 against R3. They're both 5. They're equal. That's my termination condition. I move the result R1 into R0, which is 30, BXLR, and then for some reason I go back to here. Why did that happen? Why didn't my code work? It's because I called a function from within a function, didn't push and pop the link register. Whoops, so we better fix that. That's why we debug our code. Push the link register, and then pop the link register. There we go. So then we'll save that, and we'll try again. And this time we'll just run it from main and see if we get 30 as the answer. So move a 5, we'll step over that function, and we do get a 30 as the correct answer in R0. So it looks like my code is working correctly.